In this problem, we have to design an iterator class, and that iterator would support two methods. One will be to check whether next exists or not, has next, and the other one will be to get the next. So what we will try to get here, so you must have studied about iterators in different containers in languages like, so for example, we have iterator for vector, list, and so on, and these iterate through the elements of the vector. So there the value returned are the actual values stored here. So here the iterator has to return one combination from a given input. So first there will be one input string. It will have some characters, all in lowercase English letters, in sorted order. So this may not be A, B, C, D, E. This can be like A, K, L, M, R. So these are sorted order. So this is input string, and you will be given one length, let's say 3. So what we have to do, there are different ways of choosing 3 characters out of this larger string. So that's how this combination term is coming. So choose 3 characters from this, and then these should be sorted, and first time we will return the smallest possible string. So for example, let's take a look at an example. So here we will define one constructor. There we will pass an input string S, and let's call it K. So first time we call next, it should always return, this next should always return a substring out of this, not substring, but it should pick 2 characters from this, not necessarily contiguous. And first time it should be the smallest string out of this. So smallest 2 character long string can be AB. Next smallest would be AC. Next it would be BC. So first time we call next, it should return AB, the smallest one. And has next should return true, since there are more possibilities. Next time we call next, it returns the next largest, that is AC. And again has next is true, since there are more combinations possible. And next time we call next, it should return BC. And in this case, only 3 combinations are possible due to this simple formula. N choose K. So here N is 3, the length of string, and K is 2. So 3C2 is same as 3C1, which is same as 3. So it's 3 factorial divided by 2 factorial divided by 1 factorial. So it's 3 times 2 factorial divided by 2 factorial. So this 3 is coming from that. And now we have called next 3 times. So if we call iterator.hasNext, it will return false, since we have returned all the possible combinations of length 2 in alphabetical lexicographically sorted order. Now let's look at one more example, then we will see how to solve it. So let's say we have A, B, C, D, E. So this is the input string, and K is 3. So we will start from A, B, C. This is the smallest. Then A, B we keep constant. We will change the last one, since we are looking in the sorted order. So these are already sorted, A, B, C. So we keep A, B constant. The next value is D. Then A, B, E. Then what can be the other possibility? A, C, D, A, C, E. So now we have changed the second character. So first we were trying to change the rightmost character. We have exhausted all the options here. Then we come one step back and try to change the second character, so that we have written all the possibilities with the smallest character as the first one, and this will be lexicographically smaller. ACD, ACE, and then ADE. No other possibility with starting with A. So let's write B, BCD, BCE, and BDE, and finally CDE. So how many of these are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this comes from, here its length is 5. So 5 choose 3, which is 5 factorial divided by 3 factorial divided by 2 factorial. So it's 5 times 4 times 3 to 1, that is 3 factorial. 2 factorial is 2 into 1. So this cancels 2 and it's 10. So how we should solve it? So in this problem, either you keep track of what was the last combination that we returned. So we keep track of that in our class. So we have to define an iterator class. So previous value returned, and when next call to next comes, then we will check what is the immediate larger value possible using these characters. Or the second approach would be that we pre-compute all of these and store them in a vector or a list, and whenever next call comes, we return the first one from the queue and then pop it. So once next call comes, we return ABC, then we return ABD, and we keep popping it. And when the queue becomes empty, if has next call comes, we will return false. Otherwise, we will return true. And it has been given that you have to instantiate this class once, but these calls will be made many times. So it makes sense to store them, process them once, so that all the further calls of next and has next will be O of 1. So let's see the approach. So the main challenge here lies in generating and storing all these combinations. Other than that, this next will simply return the first element and pop it, and has next will check whether this is empty or not. So the main job lies in the constructor itself. So let's say we are given a string A, B, C, D, and we want A, B, C, D, E, and K is 3. So how we generated it? So we wrote here, we started with ABC, the first 3 characters. So we can have one function, let's say this is a recursive function, where we pass the starting character, and let's keep a queue which will be empty. So this is the starting position 0 and length is 3. So 0, 3, and currently the text that we have formed is empty. And what this will do, it knows that we have to start from 0. So it will immediately append the character at 0th position, that is A, and then so we can call it text. So text becomes A, that is character at 0. Then we can call, so we have included one character, so the remaining length is 1 less, and we have included the first one, so the next starting position. So we have included A, and now we are looking for all the combinations from B to E, and its length should be 2. So we pass 1 as the starting position, length becomes 2, and the text becomes A. So we will keep appending to it. So again, at position 1 it's B, so append B to the existing text, so it becomes AB. So we call F starting at 2, the remaining length is 1, we already have 2 length, and we pass the string AB. Then it will again append this character at position 2, which is C, so it becomes ABC, and then call F start at 3, length is 0, and ABC. So in this we can add a condition that when length is 0, that is no more character needs to be added to this, we will append it to Q. So now this ABC comes here. ABC. Then this call will terminate. So we add it to the queue and return. So this will return and then delete it. So we could have written here AB plus C. So this now becomes AB, and it will again call F3. So make this text ABD now. So we had taken this C. So take the next value of next character D and again call this. Finally all of this will return AB starting with AB, ABD, AB, E. Then this call will return, and now we will remove this B also. So we will append the next character of B, that is AC, and repeat the same thing with AC as the first two characters. So AC, it will append D first time, ACD, then remove the last one, and the next character is E, so ACE, and remove the last one. Now there is no more character, so we stop. So this call will also return with AC, so it will now become AD. So in place of C we will add D, and the same thing will repeat. So AD is there, next character is E, ADE, and now there is no more character here, so this AD thing returns, and next time here we delete D also. So we have written everything with A, so this A is again returned from here, and we add next character, that is B, and again the same thing recursively repeated. So B is the first character, then starting position we will call for from 2 to length 2, so it will first append here B, C, then call with a length of 1, it will append D, and next call with a length of 0, so length 0 means we have to enter it here, delete D, add next character, delete E, no more characters, so return back, and here it will delete C and add D, and the same thing with BD, so BDE, and nothing to add, so it returns here. So now it cannot add E here since there will be no more character, so again it returns, and now the next character will be C. So repeat the logic with C, so it will call CD, and it will call CDE, CDE will be added here, it will return here, it will try, it cannot add CE since there is no more character here, so it will return with this. So how should we implement it? So here is a pseudocode of this. Let's say this is the queue which is empty initially, this is the input string, this is the length of this string, and K is the length of combination. So this is the case where we are inserting, so the required length is 0, so this text already holds a string of length K, that's why this length is 0, so we insert it into the queue. So this is very trivial, and the main body of this function is I equal to start to L minus length. So length is the required length of string. So if this is the input string and its length is L, so if starting position is here, start, then what is the smallest value that can be possible? This should be at least length. We can start anywhere from beginning till here, or start should be such that we should have a length. So from start till some point where the length is length, this required length, because if we go beyond this, if we start beyond this, then the number of characters is less than length, so we will never be able to form such string. That's why here I is from start to L, which is the length of original string, minus length. So if we start from L minus length, then if we take all the characters, it will be of length L. So that's why we will stop I when we reach L minus length. There is no point in looking forward. So what we did here in this case, so we took C, and then we did not try with D as the first character, since we know that we cannot form D, E and something else 3 character long, so we stop at C. So let's write the code for this. So the hint that is there is that generate all combinations as a pre-processing, since there will be multiple calls to these next and has next. So let's save this string in the class. So here we will save it. So S equal to this characters, and we should create a text, empty text, and then we will define a function. So we start from next one, I plus 1, and length becomes length minus 1, and txt plus starting position is 0, length is this text is empty. So this we call from constructor itself. So this will create all the combinations and insert it into the queue. So our job is very simple now. And why we are not adding here check that if it's not empty then only push then only pop, because it's guaranteed that all calls of the next are valid, so we don't need that check here. So there is a mistake here. And the solution is accepted, and we are right here at 90.27%. Now let's write this in Java and Python. So here, since we need to add to this text, we need to use a string builder, and this would be q.add. q is of type int, a string, so we need to convert this string builder to string. And the Java solution is also accepted. And again, we are in the top zone. Finally, let's do it in Python 3. And here we did not set s since it's already accessible. And the Python solution is also accepted.